In the previous video, we looked at the electrolysis of a dilute aqueous solution of sodium chloride. In this video, we'll do another example of the electrolysis of a dilute aqueous solution. This time we'll look at the dilute solution of copper sulphate. Electrolysis, dilute aqueous 2. So just to remind you, a dilute solution is different from a concentrated solution in that there's very little of the substance that we're talking about in it. So if I use, in this case, my electrolyte is copper sulphate, aqueous, and dilute. So there's lots of water for each ion of copper and each ion of sulfate in a dilute solution, whereas in a concentrated solution there will be much more copper sulfate versus water in it. And as we saw in the last video, that produces some interesting differences in the products of electrolysis. So to start, we will once again bring out our beaker and our carbon electrodes. So I'm choosing carbon electrodes. In later videos we'll look at what we get if we use non-carbon electrodes, but for now I don't want the electrodes to react with the solution, so I'm gonna choose carbon since they're relatively inert with most things. Carbon electrodes, and I'm going to fill my beaker with a solution of copper sulfate. So since copper sulfate is blue, I'll use a blue pen instead. So I have copper sulfate, aqueous, dilute in here, and in a solution the copper sulfate will dissociate into copper ions and sulfate ions. We also have water in the solution which will dissociate too. So my water will dissociate into hydrogen and hydroxide ions. So with that, we see that the copper and hydrogen ions are positive, so they will be attracted to the cathode, which is negative. So copper, hydrogen, and the sulfate and hydroxide ions are negative, so they will be attracted to the positive electrode, the anode. So I will write them right below the anode to signify that they are attracted to it. And now remember, the rules of the game are that at each electrode I can only have one species be discharged, or one particular type of ion be discharged. So for example, at the cathode I have copper and hydrogen ions, but I can't have both of them be discharged. You can only choose one. And likewise at the anode I have sulfate and hydroxide ions, but I can only choose one. So to choose it, remember we had to look at the reactivity series, so let's bring that in once again. It's the reactivity series that we had from the earlier video. So let's look at the cathode first. At the cathode I have my metal ions, so I'll look at the cation series. And now I'm comparing Now I'm comparing copper and hydrogen. So we see that at the cathode, the copper is less reactive than the hydrogen. So the one that is less reactive will tend to be the one that is discharged. So I will circle copper here because hydrogen is more reactive, so it's going to want to stay as an ion in the solution. So copper is going to have to be discharged in place of it. And at the anode, I have sulfate and hydroxide ions. So at the anode, I have sulfate and hydroxide ions. Here they are. I have sulfate and hydroxide. And so hydroxide ions will be discharged because it is less reactive, sulfate. So let's go ahead and write the half equations. At the cathode, I have copper being discharged, so copper would need to receive 2 electrons. So I just show electrons coming down here, 2 electrons from the cell to form solid copper. And because copper doesn't really stick to carbon, the solid copper will come here, be discharged, and then it will just sink to the bottom of the beaker. At the anode, I have hydroxide being discharged. So I will write, we had gone through this equation in previous videos, so I will write down this equation. When hydroxide is discharged, recall that it releases hydrogen gas and water. So to balance it, I put 2 here, and since I have 4 negative charges here, I'm going to need 4 electrons to be released here. And so the copper ions were reduced, and the hydroxide ions were oxidized. Now I can write the overall reaction. Hydroxide, oxygen gas, water, 4 electrons. And now I will multiply the cathode reaction by 2 because I need 4 electrons here to cancel the 4 electrons from the anode reaction. So I will just do that on the fly here. So multiplying by 2 is going to give me, it's going to give me 2 copper and 4 electrons, which is what I want, and 2 solid copper on the right side. So these 4 electrons cancel these 4 electrons, and so I can write my overall reaction, which is 2 copper ions and 4 hydroxide ions. This is aqueous, giving me oxygen gas, 2 copper solid, and 2 water liquid. So just to show this in the diagram, I have oxygen gas being released at the anode, and copper, solid copper, forming at the bottom of the beaker just below the cathode. So now I can identify the spectator ions, the sulfate ions, and the hydrogen ions did not take place in a reaction, so they're just watching, hence spectator ions. Now notice that as the reaction proceeds, we have an increase in the number of, we have an increase in the concentration of hydroxide ions, because this copper and hydroxide are being removed, so the relative amounts of hydrogen ions will start increasing because the other species are being taken out of the solution. So as the concentration of hydroxide ions increase, the solution becomes more acidic as the reaction proceeds, meaning the pH of the solution will drop. So if you're unfamiliar with the notion of pH or acids and alkalis, just ignore this for the moment. We will look at it in a future video. So there you have the electrolysis of dilute aqueous copper sulphate. Will give me oxygen at the anode, copper at the cathode, and a solution that becomes increasingly more acidic as the reaction proceeds. In the next video, we will take a look at some of the applications of electrolysis in industry.